Hi, I'm Donna Malieri. I'm a program manager on the Azure App Service team, and today I'm going to talk to you about how you can build great cross-platform, enterprise-grade mobile apps using Azure App Service. In particular, I'm going to show you how you can make your app both responsive and resilient to network connectivity problems by using a feature called offline sync. So let's get started. First off, let me talk about Azure. Now, a lot of people, when they see this slide, they get a little nervous because they think they need to know everything that's here. And the fact of the matter is you don't. New services come out constantly, and I can tell you that even members of the Azure team have a hard time keeping track of what's new. The cool thing is that most of these services work independently of one another, even though they do provide additional benefits when they integrate. So if you take a look at this chart and you see one or two services that you might be interested in, you can learn more. And don't feel like you need to understand everything before you can start making use of Azure for your application. And basically, use what you need, and you only need to learn what you need to use. Today I'm going to talk about the so-called app platform within App Service, which includes web apps, API apps, mobile apps, API management, and notification hubs. In particular, I'm going to show you an app that has both a web client and a mobile client, and it also has a web job that it uses to do background tasks. So let's get started by taking a look at the capabilities that you get with App Service mobile apps. So this chart might be familiar to you if you're familiar with mobile services. In fact, we have the same sections on the right. You have your data connections. We've added some new ones. We have on-premise data connections now, including connectors with Salesforce and Dynamics. And we have a DocDB access, for instance. Authentication is handled the same as usual, and push notifications as well. A new feature that we've had relatively recently is offline sync. And the way that works is that you can sync whatever data source it is that you've configured for your mobile backend to your mobile client. And we have data sync available for all of our client platforms, with the exception of Cordova, which we're working on. So essentially, your client can abstract away knowledge of the underlying data source. So you could write your app connecting to a SQL server, for instance, and then later change it to connect to Salesforce without ever changing any of your mobile client code. Now, a change that we made recently within the last year when we introduced App Service Mobile is to change the underlying compute that you use for your mobile backend. What we heard from customers was that they liked the flexibility that they got with mobile services, but they wanted more control over the compute container. We tried to make things easier by abstracting that away, but customers said, no, I actually want to be able to manage all of this. So now, with App Service Mobile, your backend is just a regular Azure web app, which was formerly known as an Azure website. So that means all of these great features that web apps has had for years and is continuing to innovate on are available to all mobile backends. So that includes things like Traffic Manager, VNet, app service environments, and continuous integration and deployment. So I'm going to give you a couple of customer examples of some really cool apps that people have built that really unleash the power of Azure Mobile and make it so that they can focus on their app code rather than focusing on their infrastructure. So if you've ever traveled with Alaska Airlines, you may have used their mobile app. Now, they also have a huge number of employee apps. One such app is Hopper, which is how employees of Alaska, including flight attendants who need to travel for work, how they actually find spare seats on flights, and they can go from one destination to another. And they need their own system because they're not obviously paying for a ticket, and they need to see what flights are available. And they had an app for this before, but it used just regular classic ASP. It was not a responsive app. It didn't work offline. It didn't work on a mobile device. And it also had a lot of missing functionality. So a group of passionate engineers at Alaska said, hey, I bet you we could rewrite this and make it way better. And if we use Azure, that'll really boost our productivity. And so that's just what they did. They built this great Xamarin app that has fantastic internal reviews. And they use Azure Mobile, and including notification hubs, and connecting onto an on-premise data source in order to deploy this app. And they really have a lot of great things to say. If you want to learn more about this, check out the videos from last year's AzureCon, where they actually have some videos showing how they built this app. Now, you can also have consumer apps. There are a lot of great ones that run on App Service. One example is the NASCAR results app that has a tablet version and a mobile version. And this app is interesting because it uses a lot of different Azure services, such as our New Relic integration, which is available through the Azure store, and of course Xamarin, which is very popular for mobile apps. And I'll show you a demo with Xamarin in just a moment. They use Redis, Microsoft SQL, and MySQL. And their website actually used PHP, which shows that Azure supports more than just .NET. Now, one more employee app, since that's the more common employee enterprise scenario that we're seeing lately, and that is the Transport for London fault reporting app. Transport for London is an organization that manages all of the transit in London. So if you've ever visited London, you've taken one of their services. Now, with a city that large, there's going to be issues that arise. There could be potholes, there could be some power line that's causing a problem for a bus, that kind of thing. And in the past, employees had to either track things down on paper and then enter them into a computer later, or carry around a heavy laptop to record these issues, because the issues need to eventually go on to some on-premise system. So what they've done is they've written an iOS native app that works offline that allows employees to take photos of issues, and this gets submitted back to an on-premise system. So in the case of Transport for London, they didn't want to move all of their existing infrastructure to Azure, but they did want to take advantage of these great offerings that we can give them, particularly in the case of mobile development. So they're using app service environments and VNets in order to securely connect back to their on-premise system. And these are just some of the examples. If you go to azure.com, you'll see that there's even more examples, including the very popular jet.com, who are hosting their mobile site on app service. So the key thing to summarize that Azure App Service gives you is a fully managed platform. It really delivers on the promise of PaaS that we heard, when the cloud came out, but it's taken time for these services to mature, and over the past several years, Azure App Service has really come into its own as a fully managed platform. The other great thing about it is you don't have to rewrite your code in order to run an app service. You just write your code the way you normally would, a PHP site or an ASP.NET app, and you deploy it. You don't have to use a custom programming model. At the same time, you get all these great DevOps features like continuous integration and deployment, load testing, and you also get these enterprise features like VNet integration, Azure Active Directory integration, and so forth. So, developers like writing code, but most developers don't want to focus on infrastructure and servers. They want to focus on application code. And App Service really frees you up to be able to focus on your app and what it does that's special, not a lot of boilerplate. So let me show you a demo of a really simple app that has both a web client and a mobile client that we've built with Azure App Service. So let me switch now to Visual Studio. And here you can see that I have a Xamarin Forms app. It has targets for Windows Phone, Android, and iOS. And I'll be demoing the iOS version of this app. So let me show you the mobile version of this app. This is a really, really simple version of, say, Instagram. like really, really bare bones. Doesn't have filters, it doesn't have tagging, but allows users to share photos. You can use social authentication or Facebook authentication. And you can upload images that are either shared or private to a user. So if we go to the web client, we can see some of these images that we've already uploaded. Now on the right, you can see there's some links to load different size images. And the way that that works is that when you upload an image from either the web or the mobile client, we have a web job that runs in the background that looks for a message that's posted to a queue. And when it sees that message, it loads up the blob and it does an image resizing algorithm in the background. And you can run this web job either on the same site that you're using to host your web and mobile backend, or on its own site. And I'm not going to show you the code for this web job, but this entire project is open source and available in the Azure samples repository. So now let's look at the mobile version of this. So now in this case, I'm logged in using Facebook. And so I see, in addition to the default album, I see a new album called Cat Photos, which I haven't added anything to yet. So let me do that here. This is my cat. And it's taking a little while because it's uploading this image. And now it's uploaded. Now, if I click on these buttons, you can see that the image size is not available yet for the different sizes. The reason is that we are not synchronously resizing this image. Otherwise, that would make the mobile client wait, which would be kind of silly. Instead, when the image is uploaded, the client sends a message to an API, and then an item is added to an Azure queue, which the web job then listens for. Now, I talked about offline sync being a very important piece of functionality, particularly because you don't necessarily always have network access, or sometimes maybe you just want to limit the amount of data you use. And at the very least, you want an app that's very responsive. So as soon as it starts up, it should load the data that it loaded previously and not make the user wait. So let us simulate an offline scenario. In fact, let's completely take off the network. And so this means the simulator also has no network. And if we try to sync here, what we're going to see is it can't work. It can't sync your offline. So, however, we've just taken this really awesome cat photo. And so it's critical that we upload it as soon as we can. So again, it's showing a message because this app assumes that you're online. It's just saying, hey, just so you know, you haven't uploaded this image. And this image doesn't show up here because it is always using what's actually been uploaded to the server. But the image is still loaded into the app. So all I have to do is turn the Wi-Fi back on and pull down to refresh. I can do that from either the main view or the cat photos view. Now we can see that the cat photo is indeed uploaded. And if we were to do the same thing, but add to the default album, let's do this photo instead, we would see the same thing. So let me turn the Wi-Fi back on and sync it again. And now the image is loaded up. And let me go to my web client because I have to go to the default album. Let's refresh this page. And we will see, and here I'm not going to bother signing in. So here we will see this new image. Here we are. Now, the image resizing has kicked in and the web job has run and resized the image. Let me show you the code briefly for this to show you how easy it is to set up both offline sync and this new feature of uploading images in any kind of blob data actually, even when the user is offline. So first, what you need to do is have a mobile service client. You use our mobile client SDK. Here I'm using the one for Xamarin, but we have it for Android and iOS, as well as Cordova. And we create a SQLite store, which is how we're going to actually store the structured data, not the image data, but just the structured data. And then we create some local tables. Then we create sync context, which is essentially tracking all of these changes that we made while we were offline. And the other thing that we're going to do is set up the local store so that we get callbacks whenever there are local or server operations. And this is a new feature that we've added with our file sync support. And it means that you can either write your own code that synchronizes in the background and refreshes the UI by listening for these callbacks. Or in the case of the file sync API, this is how it actually finds out that there are new records, and then it makes queries to the server to find out what images are associated with them. In order to actually sync, it's super easy. You just push both the file changes and the regular changes and pull the albums that you want. In addition, when you're using file sync, you're going to want to write a file sync handler, which again is also really simple. You set a file data source. In this case, I'm using the dependency service pattern in Xamarin, and so I have a simple class that just loads different classes to actually load the image from the device, since that is platform specific. And then a file synchronization action is going to get triggered whenever there is a change to a file. So that's why that listener is being used. It triggers this callback. So here, if you are, in the case of delete, we're going to delete the file. Otherwise, we're going to download the file. And that's how it works. And the key there that I showed you was offline sync. And the reason is that nowadays you can't always assume network connectivity, and users are expecting more from their apps. Even if they aren't some app that's critical to work functionality, people want to be able to use them and sync data later. The problem is that the reason that most apps don't have offline sync is that it's usually really hard to get this functionality to work. It's relatively easy if you only want read-only data, but as soon as you start changing data, and the data can be changed by multiple people or even just multiple devices, then the problem of doing sync becomes really hard. And so, in the spirit of app service, in order to let you focus on your app code and not boilerplate and infrastructure, we have these client SDKs and server SDKs to make this super easy. So the reasons for doing offline sync are basically what I said. It could be just as simple as making your app responsive, or it could be the most interesting case where you have multiple users editing the same data, but you want to make sure that they don't stomp over each other's changes. So we also include conflict handling. So the way it works is that the client SDK, the offline sync feature of it, keeps track of all the changes that are being made when the app is offline, and it saves these to a queue. And then when the app detects that it has network access again, in the case of the app I was showing, it always checks for network access. And so the sync action is triggered by the user actually pulling down to refresh. At that point, the app calls the push and pull methods. And what push does is it finds all these changes that were in the sync context, and it sends them one by one to the server, ensuring that the operation is preserved. You can also use this feature in conjunction with Azure notification hubs and have your server actually send silent or raw push notifications to the client so that the client wakes up and then downloads data. And you can even do this in a background task so that the app always has the freshest data. So to summarize, what App Service does is that it provides the infrastructure so that you can run your mission critical or even not so mission critical web and mobile apps. You can have these apps scale with your business. You can start out small with the free tier and scale all the way up to hundreds of instances that run in an app service environment. So let us do the infrastructure and you can write your app. Thank you very much.